All right, let's do this. So on page 13 in your notes packet, what I would like you guys to do at the top is write SOHCAHTOA. If you remember how to spell this, you will remember the trig ratios that we're going to be doing in this section. So notes packet, put your phones away, unless you're using it as a calculator. Make sure your calculator is in the degree mode so that this is highlighted, otherwise you're going to get the wrong answers. Okay? So SOHCAHTOA has three parts to it. SOHCAHTOA. Each of those stands for sine, cosine, and tangent. Those are the three trig ratios that we're going to be learning about. What do they mean? So, the sine stands for opposite over the hypotenuse. Cosine stands for adjacent over the hypotenuse. Tangent stands for opposite over adjacent. Now, why do we even do this? You guys know that I like to tell you why we're doing this. So just to kind of paint a picture, so far we've been doing Pythagorean theorem problems, or maybe even we mentioned triples. If I showed you a triangle, you don't have to write this down. If this is 3, this is 4, what's this? 5, right? It's the hypotenuse. We could use Pythagorean theorem, we can find it. What if I gave you a special triangle and I said this is 8 square root of 2? These are both 8, correct. So we know how to find sides in the right triangle that have 2 sides given. We know how to find it if it's like 45, 45, 30, 60. But what about a random triangle that has an angle that's 23 degrees? In fact, there's way more triangles like this that have different angles, like 48, 56, 81, blah, 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 blah. So many different angles. How do we work with those? Let's say I tell you this is 15. You will be able to find both of these sides in just a few minutes using either sine, cosine, or tangent. That's what we're doing, okay? When you're looking at the word SOHCAHTOA, why do we even write this? The sine stands for opposite over hypotenuse. So that's the OH. Cosine stands for adjacent over hypotenuse. Tangent stands for opposite over adjacent. So any quiz, test, worksheet that you're going to do, bless you, you can write this at the top and you will never mess up the ratio. Okay? So here's what we do with it. This is the right angle. My favorite triple is 3, 4, 5, so I'm going to go with that. And we're going to write down the ratio, because a trig ratio simply means when you do the sine of an angle, you're simply dividing 2 sides of a triangle. So sine of A, angle A is right here. We're going to take the side that's opposite divided by the hypotenuse. So in relation to this angle, this is always the hypotenuse. What's opposite of it? 3. 3 is opposite of angle A, so this is going to be the opposite. Some people like labeling it like this. And what's adjacent? Now, adjacent means next to. So this side is also next to angle A. However, 5, side AB, is the hypotenuse, so it gets the name of hypotenuse no matter what. And the one that's next to it is right here. That's called adjacent. So the sine of A is going to be 3 over 5. And that's it. We just wrote our first trig ratio, 3 over 5. Then we have cosine, which is going to be adjacent over hypotenuse. So the side that's adjacent is 4. The hypotenuse is 5. Tangent is opposite over adjacent. So you look at the opposite side divided by the adjacent, so it's 3 over 4. That's it. That's it. That's all there is to it. But now, how do we actually use this? So, before we start using it, let's practice. Express each ratio as a fraction. So here we're going to do it for angle P, and then we're going to do it for angle Q. So P is right here. In this triangle, which one is the hypotenuse? 17. And now in relation to P, what's opposite of P? 15. So for the sine, it's going to be 15 over 17. Cosine is adjacent, so that's going to be 8 over the hypotenuse, which is 17. Tangent is opposite over adjacent, so that's 15 over 8. Why don't you guys do the same thing, but now switch your perspective and do it starting with angle Q. Again, this would be the hypotenuse, but what's opposite of Q now? 8 would be the opposite, 15 would be the adjacent leg. That is correct. For this, you should have gotten 8 over 17. Here you get 15 over 17. 8 over 15. Do you notice anything? Some people notice patterns in my other class. Wait, have we done like 8 over 17 somewhere? Cosine of P is 8 over 17. Sine of Q. So what happens? The cosine from here becomes the sine. The sine from here becomes the cosine, and what happened to the tangent? They're flipped, the reciprocal, because for this is the opposite now. For angle P, this is the opposite. So if you find sine, cosine, tangent of one of the angles in a triangle, that's always going to work out that way, that the other angle will always have a flipped tangent and these will swap. One thing you have to know, you will never be writing like sine, cosine, or tangent of 90 degrees. We will not be doing anything with that. If that is somewhere, then that's wrong. That's not correct. Okay? You always do it with the acute angles, either this or this. All right. How do you actually use this? Actually, why don't you guys try these problems right here, A and B. But first, let's find X. If you were here on Friday and you did triples, do you happen to remember what goes with 5 and 13? 12. If you forgot, or if you don't remember, or if you weren't here, you would simply do Pythagorean theorem. So this side is 12. You would do the same thing for B. Find X, and then write each of the sine, cosine, tangent for the angles. Why don't you guys take a minute right now to do that?